Okay, so we have a data set, and we're asked to calculate the test statistic for the differences in the sample means. So we have two columns of data, website A, website B. Each column can have its own mean, each column can have its own standard deviation. And since it looks like they're two different websites, the test statistic we need is this one, where we're calculating the difference between two independent means. If it was a matched pairs case, then the calculation would be different. You calculate a difference column and then use that standard deviation of the differences instead of the standard deviation each column separately. So basically what we need is the mean of each column and the standard deviation of each column and then the sample size. That's just the number of numbers. So we'll click on this data set. I'm going to click this thing on the top to copy it, and then you can go to Excel. Oops, I got to finish copying it. And then you can go to Excel or Google Sheets, and then mean of A, we need the mean of B, and then they need the standard deviation of B. So the mean of A, we type equals average, open parentheses, and it starts in A2 and then it ends on A31. That's all the cells. So put a colon between the first cell and the last cell, and then it'll know to find the average between all those numbers. And then the same numbers for B equals average, except it's B2 to B31, I think. You can click and drag too. And this is Google Sheets, but it's the same thing in Excel. Same thing. Standard deviation, make sure you're using sample standard deviation. So type in equals stdev.s, and then it's A2 to A31 again. There's our standard deviation, and then equals stdev.s, B2 to B31. Okay, we got all the numbers we need for our test statistic. Now we just have to plug them in. And this is the hypothesized value. And since we're asked, I think, to calculate the difference between the two, like the hypothesis that the two are statistically significantly different, yeah, then that's just 0. So this number over here looks funny, looks crazy, but it's just 0. Okay, so the mean of column A actually matters which one is A, because it'll be negative or positive. I don't think it's, oh wait, no, it does say. Website A is the first one. Okay, so website A is 8.8 for the mean. Website B is 7.96. I'll carry some decimals until the end. We'll round at the end. And then the standard error is over here, so it's the square root of the variance. So our variance was 4.054797. And then we got to square that and then divide by the sample size. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 30 data points. There's obviously quicker ways of checking that too. But okay, that's the first fraction, plus 4.21396 over 30. And then we square that for the second fraction. Now we're ready to calculate. Numerator's nice and easy. 0.83 repeating. In the denominator, I'm going to do the squaring first. So we want to square that. And then over here, we want to square 4.21396. I'm going to clean it up in just a second. That's going to round up. That's again over 30. Okay, so this is what our denominator looks like. It's the square root of all these numbers after you've divided and then added. So I'm going to do 16.441 divided by 30, 0.548. Gotta do this. And then we got 17.75746 divided by 30, 0.591, and that probably repeats, so we'll stop there. Especially with the square root, you need to carry out some decimals. And then square root the denominator, so we get 1.067668 for the standard error. So I took the square root already, so now we're at this part. Okay, so 0.83333 divided by the denominator. That's 0.78 for our test statistic, and I think they say 2 decimals. Okay, the degrees of freedom, it's just a pretty complicated, ugly formula, but at least they put it for you there so you don't have to go hunting for it. This is usually where software comes into play too. Excel, I don't think I've ever found it in Excel. I don't think it exists there. You might be able to find it online, but it's just, that'd be hard to dig up that video. The degrees of freedom is just this long, cumbersome calculation for independence of two, for calculating the difference between two means that are independent. So it's brutal, but we can do it. Okay, so it's standard deviation 1 squared okay, I'll just write it out first. That means squared. Oops, and that's going to be divide, I forgot. So that's this squared divide by n1, which is 30. And it's plus second standard deviation. It's going to be squared. That's again divide by 30. So we're going to divide those, figure out that numerator, and then we got to square the numerator. Then down here it's 1 over, this is 30 minus 1, so it's 1 over 29 times this standard deviation up here is squared. So it's this same thing down here. So let me copy and paste that. Yeah, it's that fraction squared. So I just wrote this out. And then it's 1 over 30 minus 1, so it's 1 over 29 again. And then it's times this fraction. But we've got to square that fraction again. I covered it up a little bit. I gotta move that over. There we go. Squared. Okay, I think I got everything copied over. Now just long, tedious calculations. Skipped ahead a little bit. This is what I got for this. This, I got this. And then this term I simplified to be this. And then this term I simplified to be this. So almost done finding the degrees of freedom. Let's do the denominator first. So I add those up. This is what I got for the denominator. And then the numerator, 0.548 plus 0.5919157. Got to square that. That's what I got for the numerator. Oh, I see. Okay, that needs to, that's okay. So it's that 1.299 divided by the denominator. Oh, did I square? I don't think I squared it. Let me just double check. 0.548 plus 0.59191. So many opportunities to miss something here, huh? Okay, so I got that right. Okay, so for the degrees of freedom, I got, after I did that huge formula, I got 57.914. Rounded 2 decimal places. So I got 57.91. Thank goodness. I was going to be really upset if I had to go find that. Okay, there's a different rule that you can use. This is what you would use if you don't have if you don't have a computer that's getting you the degrees of freedom. It's the minimum of these two. So look, the first number, 30 minus 1, that's 29. The second number, 30 minus 1 is 20. It's the smallest between those two. That's what that function means. And since they're the same, the smallest number in that list of two numbers is 29. And then this question wants you to find a p-value. You could do it with an integral and calculus, but let me pull up a website for you. Okay, so this is the website I'm about to use on screen. Pause the recording if you want to type that in. The reason why we have to use a computer is because the only other way is calculus, because this is like an area under the curve problem. So I forgot what we have. Use the degrees of freedom from part B. So they want us to use 57.91. 57.91 for the degrees of freedom. And the t-value we got was 0.78. And the significance level, you can just ignore. The tail part does matter. They said it's a two-side test, so make sure you choose two-tailed. P-value is 0. Blah, 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 blah. 3 decimal places, so this rounds up to a 9. P-values and the degrees of freedom from part C, so this is where we just go back to the same calculator but use 29. Keep it two-tailed. P-value is 0.442 when you round to the nearest, so 0.442 when you round to the second decimal place. So what do we conclude? Our p-value is high. We can't reject HO. It's when the p-value is low that we reject HO. There is not sufficient evidence to support their claim. If the p-value is low, you get sufficient evidence. If the p-value is high, you do not have evidence.